Good afternoon, everyone. My name is Timur Kristóf, and I'm here with my friend Márk Sági-Kazár to talk to you about open source development, so about contributors, maintainers, and everything in between, meaning the people who participate in the development of open source software, and how it works, how you can get into it. So first, just a thought. What exactly is open source? So most people think open source means that you have the code somewhere available and that's it. But maybe there is a little bit more to it and a little bit more nuance. But who are we to tell you all of this? So about me, in a few words, I'm working on the Linux open source graphics driver stack. I've been working for 6 years on that as a contractor for Valve. I've been mainly contributing to the Vulkan driver, the shader compiler, and more recently a little bit to the kernel driver as well. So, and my latest project was about making the driver stack work on older GPUs. Márk, would you tell us a little bit about yourself?
Yeah, sure. Hi everyone, my name is Márk. I'm a CNCF ambassador and an active open source software contributor and maintainer for almost 2 decades now. I think my first contribution was at the age of 14, so it was quite a bit of time ago. I think I probably contributed to thousands of repositories at this point, maintained quite a few repositories. And a little bit of shameless plug, if you want to learn how Kubernetes works, check out my latest course that dives into Kubernetes.
So let's get back to what is open source. Some people still believe that open source means that there are some hippies in their mom's basement working for free. But I think these days there is a little bit more to it. Open source has become a business model for some companies. It has become a tool. It has become a way to innovate, a way to collaborate between different companies. So in the previous presentation, we heard how they collaborated with Google. So I think that was a beneficial collaboration because Shaper 3D got out something from it. Google also got out something from it. So it was a good model, even though it's not perfect, of course. The other thing about open source is that it gives you independence. As opposed to a closed source project, you can take the code, you can make all the modifications you want with it. If you have problems with the code, you can solve them yourself, as we saw in the previous example. And that means that you don't have to wait for the vendor to do it for you. So if you buy a product, but it's missing some features, you don't have the code, you cannot add the features, you cannot solve you cannot solve your problems. But if the code is there and you can modify it and redistribute it, it means you can unblock yourself, you can solve your problems. So it's also about ideology for a lot of people. It's about providing free alternatives to many softwares that we use every day. What do you think?
Well, these are the traditional reasons to do open source, but nowadays there are other reasons to use or maintain open source software. One of the most common reasons or use cases for open source on the consumption side is obviously the economic reasons, time and money that you don't have to invest into building something that you can just use from an open source library. You can also use the expertise of the people who have built those libraries. So it's, as we saw with the Shaper case as well, they managed to get funding by using open source. Also these days, on the consumption side as well, it's a risk mitigation strategy. If you think about, especially the cloud native ecosystem these days, it's basically dominated by startup companies, which is a huge risk for large corporations because startup companies can basically go under any minute. So relying on software made by these companies is a risk for them because if the technology goes away, then they are basically fucked. So by open sourcing the core technology, even if they build some product around it, there is no risk of the technology disappearing in a moment. And last but not least, on the maintainer side, there is a huge marketing value these days in maintaining open source software, by giving something to the community, building a community around the project. And obviously there are good and bad examples of this. CNCF is obviously a good example. They maintain dozens of open source projects that the whole ecosystem use. And obviously bad examples, the kind of bait and switch license changes that we've seen in the last couple of years, that happens as well. But how do you actually get into open source? How do you contribute to an open source project?
Well, the obvious way is that you take the code and you write your own code on top of that. But this is called a code contribution, obviously. But is this actually the only way? But before I go into that, how do you even do a code contribution, or where do you start? And for that, my advice would be try to kind of scratch an itch. That is, solve a problem that you have yourself, for yourself. So many people try to start it by just getting something random, and then they never have the real motivation to do it because it's something that they don't use or it's not important to them. So choose a project that is important to you, with which you have some problems or missing features, and contribute to that. But what else is there?
Well, obviously there are many other ways to contribute to a project, and these are also, or these are usually much more important than contribution, because there are lots of people who want to contribute code, but there are other things in an open source project that are often overlooked by the maintainers because they don't have enough time, but by the community as well. So if you want to contribute to a project, but it's not code contribution, and by the way, there can be 1,000 reasons why you don't want to contribute code, because your company doesn't allow it, because you are not familiar with the language the project uses, or a number of other reasons. But you still want to give something back because you use the software, not necessarily as a library, but maybe as a desktop application. So how can you do that? If you think about, let's call them material contributions, you can write documentation, and it doesn't mean that you have to write whole pages of documentation. If you see something, just fix it. If something, there is an error in the documentation, just send a pull request and fix it, and it's an invaluable contribution to projects. There are lots of projects that need translators so that other people, not necessarily software engineers, can use the software in their own language. That's another material contribution that you can do, and you don't even have to know the language that the software is written in. If you're a people person, you can also help with the community. You can organize community events, community calls these days, or you can provide support to other people who use the software on forums or issue trackers. That's also a huge help to the maintainers because they can focus on other priorities. Another often overlooked but invaluable contribution is testing pull requests that other people send in. Maintainers can't possibly try every single feature in every possible combination. If you use a software, just try new features pull request in your environment and give feedback or report issues about those pull requests, and then the maintainers can have a better picture of whether the pull request is valuable or it can be merged or not. If you have a favorite Linux distribution or some other packaging or ecosystem integration that you'd like to see in the projects, but the maintainers are not involved in the ecosystem, then you can contribute that yourself to the project. And last but not least, you don't have to be part of the project to talk about it, to educate other people. Case studies are often invaluable contributions to the project because it shows other people how the project can be used in a real-life project. By the way, any of these contributions are often the first step of becoming a maintainer of a project if you have such ambition. But what is it like to contribute? What's the process? And we would like to show that to you by telling you a little story. So a couple of weeks ago, obviously everyone uses open source these days. Who uses open source at work in some form? Okay, a lot of hands, cool. So I use open source for my work as well, and often these open source libraries are really shitty, right? So they often miss obvious features, and you want to add some feature to a library. Let's see how it goes. How hard can it be? That's usually the thinking behind when something is missing from an open source library. So I try to do it myself. I've spent hours on the weekend to set up the developer environment, which is pretty hard. I don't know why the maintainers make it that hard. I went through the 4 pages coding guidelines. Again, I don't understand why there are so many rules in an open source project. It's just bullshit. But I finally cracked it. The code was perfect. I'm a good programmer, so I write perfect code, obviously. And it works on my machine. And this is where the problem starts. Like, I submit the pull request, and what happens? There are no response for 3 weeks.
From the maintainer's perspective, well, you know, when you're maintaining something, you get an email notification. Somebody opens a pull request. You look at it. Who is this guy? Well, what does he want? Why do I have to deal with this now? You know, the branch point for the project is this week. I'm busy with doing that. So I'll just read it later, you know. Okay, so after reading it, I think that the contributor didn't really test this. So I ran the CI. I don't even know why I had to run it. Why didn't he do? But anyway, I ran it. It failed. So just I'm just going to write. Please fix it.
Why would I write tests for 12 lines of code? Seriously, I mean, I'm a good programmer. I can write perfect code.
Well, it's actually a cross-cutting change, all of the code base, and it affects 2,000 lines of code. There is no explanation. The whole thing is just one commit with no commit message, no tests, and it breaks the CI.
But it's really just one function that's important from the whole pull request. The rest is just some refactors because, let's be honest, your code is shitty. Sorry. So that's why I had to change 2,000 lines.
Yeah, well, those were architectural decisions that the previous maintainers made in 2016. It's not something that we are going to change now, and it just causes a lot of code churn, a lot of change for no real reason other than just to change. So please don't do that.
I mean, why do you even have a CI system? Why do you even have tests? Like, can't you write good code? Seriously? And this is a simple library. Like, it doesn't even need testing. You just use it. That's how you test it.
Well, you need to pass the CI anyway to avoid breaking other users other than yourself. All right, another review cycle, and it's tabs versus spaces. Like, why do we even care? How do we format the code? Does it work or not? Well, there is a coding style guide that people should usually read before contributing, where everything is explained how we do it and why. But mainly what's important here is to be consistent with the rest of the project. So if you like tabs, great. You can use tabs in all the projects that you make. But in the projects that don't have tabs, adding tabs, it kind of stands out of the whole thing, right? Okay, looks like the guy is not replied still for 2 weeks. I guess it's not such an important feature after all.
I mean, I do have a life. Don't you? By the way, I hope the PR is going to be merged by the time I get back, or else. So I came back from the holiday, the honeymoon. The PR is still not merged. I mean, are you shitting me? Again, another review cycle, more tabs versus spaces bullshit. And some test failures. Again, I still don't understand why I have to write tests or care about them.
Yeah, well, there is still stylistic issues here and there, and you can read that also in the guide. And then there are still some failing tests. So just please fix. Okay, now that it's actually there, I noticed this doesn't work on 32-bit ARM big Indian platforms, but that's what 70% of our users are using. So please don't break all of those users.
Why is this my problem? It works on my machine, and by the way, who cares about those DAT platforms anyway? It's your problem, solve it. All right, I fixed all tabs versus spaces problems. My fingers are really tired from pressing spaces. The tests are finally passing. Are you gonna merge it now or what?
This is the third review pass that I'm spending on this. What a waste of time is this?
One eternity later.
Okay, it looks good to me now. Click merge. I guess someone will fix it later.
Fucking finally. I mean, 4 review passes, and it was free work from me. So I don't understand this whole shit show. But I show them how it's done. My code is in their repository now. I wonder what's next. Like, I've finally learned how hard it is to work with them, but maybe next time it will be easier.
So I think this feeling very often comes with a successful pull request or merge request when, well, you feel that you suffered a lot, it's finally happening, it's finally there. And in that case, usually I guess it's not so bad. We just played it a little bit. But usually keep in mind that the first contribution you're going to make is also the hardest contribution you're going to make. After you work together with some other people on the project, you're going to learn how they do things, how the project is built, how the code is structured. Probably the second one is going to be easier, and a third one even easier, etc. So don't give up at the very first one, is the point. Okay, so now that we illustrated how it works, I'd like to talk about a few concrete examples. So one of maybe the biggest open source project that everybody knows about is the Linux kernel. And one of the, let's say the most prolific kind of contributions is when a company picks up a project and chooses to contribute. So for the Linux kernel, there are a lot of drivers which are made by their manufacturers who are basically working in open source. So I think the most prolific, the most high-profile example for that is the open source driver from AMD. And with this, I think the efforts started more than 10 years ago. And I would say by now, it's something that everybody regards as basically one of the best drivers that they have in the Linux kernel, also one of the biggest. So if you look at a graph of like how much percentage of the Linux code base is like what, then you will see that a large percentage is just this one driver. Apparently, who would have thought that GPUs are complicated? But I think that this is an open source success story, and it's an example that many other companies can follow. And of course, it's very good work that they are doing, but they are not doing it only out of the goodness of their hearts. I mean, they have good hearts. I know some of those people. But the reason they are doing it is because they have clients who are relying on it. They have a business case, they have a business need to write these drivers, and a lot of clients expect open source drivers. So one example of that would be, for example, Google. So if you heard about, for instance, Chrome OS, they mandated open source drivers from all the device vendors. So from like a hardware maker's perspective, if it doesn't have an open source driver, then it's not going to be a Chrome OS device, which is why a lot of vendors did some open source work for that. Another maybe less positive example would be the Bcache FS file system, also from the Linux kernel. So I think everybody here at least have seen some memes from there. I mean, Linus Torvalds is a very prominent personality, so you know he has a certain style, a certain way to address things that he doesn't like. And in case of the Bcache FS file system, the issue was that they just couldn't really figure out how to communicate well. That would be my outside perspective. From the inside perspective, from one side, the problem was that the development cycle was not fast enough. So the developer of the file system wanted to fix things, but each of the fixes changed a lot of code, which then they didn't want to accept only in the new release, but not the previous one. So it was a huge conflict, which ended with them removing this file system. So that would be how not to do this. So the takeaway from this is that when you do some contributions, do talk with the maintainers, with the leadership of the project that you are contributing to. And my recommendation would be to start talking to them on how to do it, what to do, even before you write a single line of code. Because then you will get all the information and all the guidance that you need. So it's not a good idea that you do all that work only for it to be rejected or removed later, or to get into conflicts on how to even do it. So best to just start the conversation early. Another one, something that I worked with personally, is a fragment shader interlock in the Redvi Vulkan driver. So I'm not going to go into the technical details of what is this, because it's a complicated and very technical feature, but I wanted to just point out this as maybe one of the best external contributors that I have seen in my daily work from somebody who is not working directly for the same company that I am. So there was a guy, very enthusiastic, very clever, who made a merge request in our repo. And well, it was a process, but we communicated, and basically after a few redesigns of the thing and a few simplifications, it was merged, and it's still working, still functioning, still being maintained even today. And here, I think the takeaway is that when you are contributing, you need to consider that the code that you're contributing is something that then the other side, the maintainers of the projects, are going to be maintaining forever, or maybe not literally forever, but for the foreseeable future. So it has to be something that is maintainable, that is readable. If there are new contributors in the project, they need to understand it. They need to be able to extend what you just did. And I also wanted to talk about AI. So I think everybody has seen some, or maybe worked with some AI-based code, like code written by AI. And I think that it's something that is very prevalent in many discussions that the software engineers have these days. So with this, I would say I personally don't have a good experience, because there's a lot of people who are non-technical, and they ask AI to write some code for them, and they send the code to the maintainers. They read it, it doesn't make any sense, and then the contributor gets offended by that. So I think that it's really something that the open source community needs to figure out eventually. But I think for now, what most projects are doing is that they are writing some policies, or writing some kind of guidelines about how to use AI, or what is expected of you if you use AI. So be respectful about that. I mean, from my perspective, there's nothing wrong with using AI. but it doesn't reduce my expectations towards the contributions, right? So I don't care how you wrote the code, but it should be up to the standards of the project, regardless it's AI or not.
All right, so hopefully our little stand-up here gave you some ideas how not to conduct yourself by contributing to an open source project. But let's take a look at some actual examples of mistakes that contributors can make. And if you notice that you do any of these, then you probably have to look in the mirror and take a step back. So very often contributors believe that the maintainers reject a pull request because of their person, which is obviously not the case. I mean, sometimes it's maybe the case, but most of the time when a PR gets rejected, it's because of technical reasons.
So they don't hate me?
I don't, I love you. So don't take things personally when you get some maybe negative comments back. Yeah, this is the most annoying, probably. One of the most annoying problems wearing my maintainer hat right now is when someone submits a pull request, it has some problem in it, but it actually solves the real problem, but they refuse to actually fix the issues with the pull request. Don't do that, please. It's just wasting the maintainer's time. And you might be feeling good about yourself giving something to the project, but you're actually wasting the time of the maintainer. So if you contribute something, take responsibility for it and fix it if it's not up to these standards. This is something that companies do often when they want to contribute or give back to the community something. Companies often fork libraries or open source software, make changes, and then they want to contribute those changes back. So they open one huge pull request changing 20,000 lines of the library or the software without talking to the maintainers. And they are surprised that it's not going to be merged. It's impossible to review large pull requests. I mean, there are several studies that show that pull requests above, 500 lines basically don't get properly reviewed. So if you want to contribute to a project and if you have a lot of contributions that you can give back, it's a process. You have to go through that process, talk to the maintainers, and don't just throw it over the wall and expect the maintainers to fix it and accept it. This is something we also showed in the stand-up part of the presentation. It works on my machine. The maintainers will solve the rest. Don't do this. This is annoying. This is another time waster for maintainers when you don't fix your code or expect the maintainers to fix your code. Don't do this, please. And this is another favorite, the quick and dirty fix when you just click the edit button on GitHub, change something in the code, and then CI breaks and you don't follow the coding conventions. The editor on GitHub uses a different indentation size. That's not going to be accepted, obviously. So don't do quick and dirty changes. Go through the process. It's actually a good learning experience.
So now that we saw some of the typical mistakes that contributors to the project can make, there are also typical mistakes that maintainers of a project can make. And one of the main ones, it's not even specific to open source, but if you contribute to open source, you will see this kind of attitude publicly and more prevalent sometimes, is that people believe that they tried something maybe 10 years ago, maybe 5 years ago, it didn't work, therefore it is not possible to do, and if you try it, you will get rejected. Without even discussing it, without even giving you reasons, you don't even know how or what they tried exactly, but they tell you, this cannot work, and done. And another thing that we see, not just in open source again, but many times, is that the people responsible for the project, they look like they live in an alternate universe, and they have no idea how the project is used or who are using them, or what platforms they are using. They have an idea of like why they made the project or what they think it's useful for, and they are disconnected. They are living there in the top of this tower. They don't see anyone else that is not in the tower with them, so they don't know what the project is used for. And then if you tell them, they will disagree with you. The other thing, when you get a code review and your reviewer says, okay, this all that work that you did, very good, but one more thing, please also, while you are at it, since you are already modifying this code, please also add this and this other new feature, or please also check this and that. And obviously the problem with that is that it's very grating, because for the contributor, they want to contribute a specific thing, so they did the specific thing as best as they could, they fixed it up, they made it up to standards. So then don't ask them to do even more and more. Like maybe they will do more on their own when they are ready or when they have time. But don't gatekeep something just because something else is not there, unless the two things are actually necessary together. And with that, it's actually connected also with this never-ending story. I used to have a colleague at a previous job, and he had to review everything. And he did this at a speed of 1 comment per day. So every day I got a review comment, I fixed it, I pushed it, I asked him to review it again, then he wrote another comment. Maybe a week later, he forgot his own previous comments, and he asked me to change some things back to how they were originally. So if you're a reviewer, and if you are offended by hearing this, then, like Márk said, please look in the mirror. Please don't do this to yourself or to your colleagues. Because open source developers that you are working with, they are your colleagues, even if you are not working for the same company or from the same office. You need to treat them with respect. And this one, well, I think everybody here, maybe, who contributes to open source has this experience that you spend hours or weeks making something work to a high quality, but then somebody else submits almost the same thing. But what they submitted, they don't get any comments. It's just, oh, looks good to me. Nice to see you again, by the way. So it can happen that people play favorites, that if there is a contributor that they already know and trust, they will accept things without actually looking at it, or without scrutinizing it as much as like a newer contributor. And again, as a maintainer, I would say this is bad practice. You shouldn't do it. You should give everybody the same attention. I mean, it's okay to have some level of trust, but don't accept something that is of lesser quality, even if it's from somebody that you know. And lastly, when you have a technical discussion with a project maintainer sometimes, and they are telling you, no, you're not going to do this, not on my watch, I'm not going to let you. It's a kind of a gatekeeping behavior. And again, it can be very toxic and very limiting to the project. So how do we avoid all of this? How do we make it a good experience to actually contribute and maintain open source software? Well, first, reflect a little bit and try to avoid the typical pitfalls yourself.
Obviously, not everyone is nice people, like Linus Torvalds is one example probably. So be prepared for some attitude. You don't have to expect it from everyone, but there will be some attitude from some people. Don't take things personally. Just be prepared.
False assumptions kill. Don't assume things about other people. When you get like a pull request as a maintainer, don't assume that they are doing something that you tried 5 years ago. Like, at least read it before you judge if it's the same thing.
Yeah, obviously, the most important thing is there is a human being on the other side. You are talking to a human being, or probably you're writing to a human being. So just keep in mind, you're not talking to robots. PRs are reviewed by people, or maybe these days AI, but people get tired. People have a limited amount of time that they can spend on these things. So keep that in mind.
So you need to communicate, and you need to develop some communication skills. And please also think about the cultural aspects. So if you're working together from somebody from the other side of the world, they might understand things differently compared to you. They might have a different way of expressing themselves compared to you. And if you don't understand that, you can get offended about something that is for them not offensive, or maybe they will feel offended by something you say, even though for you it's something completely normal. So be polite and respect other cultures.
And if there is one thing that you take home from all this, is just be a little bit more empathetic. As I said, there is another human being on the other side. You may get impatient with them, they may get impatient with you, that you may get a negative feedback from them. Just be a little bit more empathetic with them. Thank you very much.
Thank you for your attention.